Cloud offers enormous potential. In my section, I'm going to talk about the benefits of moving to the cloud, the different on-ramps to get there, and the challenges associated with each of those, and how Redis Enterprise Cloud is built for you no matter where you are on that cloud journey. The cloud provides enormous value, right? The ability to build new applications quicker that are driving the new revenue streams for your business. Consolidating data silos, simplifying operations, and cutting down on costs, which is why most folks move to the cloud in the first place. Scaling your business up and down instantaneously with elasticity. Think about retail, things like Cyber Monday, flash sales, Black Friday, for example, right? Where you have to scale up your business very quickly and bring it back down in a very short amount of time. The cloud is built for these types of use cases. And cloud-native applications are disrupting businesses no matter what industry vertical. So always on, always working apps that need 24/7 flawless customer experience because they're always at the fingertips of users. And by the way, competition is one click away. But the cloud also brings about inherent challenges. So one on-ramp to the cloud migration. It's typically how folks do it, lifting and shifting on-premise workloads to the cloud, whether that be private or public. In this world, you need hybrid compatibility. You need software and technology that's going to run both on-premise, but also in the cloud. Data silos are created because you're running data on a different environment versus the new cloud that you're running on. Availability as you're lifting and shifting mission critical workloads is absolutely critical to make sure that your users are still taken care of. And the cost associated with the cloud can get out of hand very quickly if not done correctly when you're doing cloud migration. This is oftentimes considered cloud sticker shock. Microservices compounds this complexity completely, right? As we lift and shift our infrastructure to the cloud, we are also breaking up our monolith many times, oftentimes with the end user in mind. Our mission critical applications that are built for end users and are customer facing, we break those up first so they can be more agile, so they can be faster and innovate on them very quickly. But this data layer, it creates a whole new complexity. It can become expensive, complex, and slow very quickly with a decentralized database management architecture, which a lot of folks are starting to leverage, where you have a data store or database per each service, as opposed to one unified data platform built for these modern applications. Cloud native brings about a whole new set of challenges. Microservices, containers, and serverless functions that are completely ephemeral, scale up and scale down in seconds. This hyperscale and elasticity is something that's completely new to platforms. Often a lot of these legacy platforms not built for them in the data world. The hybrid and multi-cloud compatibility that's needed for this new world as customers start to shift and look for optionality, and global data distribution, because the lower barrier of entry to scaling up a region in Europe or APAC is very simple versus when you had to build out a data center and manage that to be able to serve customers in a different region. And if we step back for a second, really, all we've been talking about here is data is at the root of most challenges. 91% of organizations moving to the cloud specified mass data fragmentation as the cause of not fully realizing cloud benefits. That's huge. It's a huge concern for businesses, and data challenges are only growing, right? In a previous world, consumers created and managed a lot of the data. Now is completely shifted to enterprises, businesses. Data is the lifeblood of business, always has been, but is scaled exponentially up. 175 zettabytes of existing data will be created and managed by enterprises in just a couple of years. Just think about use cases like IoT and the edge computing, a proliferation of data that's going to be coming online that we've never seen before. And so as we think about shifting to the cloud, we also have to be thinking about the data layer and how it has to be reimagined in this new world. Now, Redis has been a core technology for users on their cloud journey. It's been popular due to speed. It's the most launched Docker container and Docker Hub, 5.4 million launches. It's just absolutely incredible. It's the most loved database technology in Stack Overflow, the last 4 years running. And the key there being database, right? Most folks think about Redis as just a caching service, but at Redis Enterprise, we've built on top of it a data platform and database, and a lot of users, we've seen a tremendous amount of growth in the ability to use this as a database. And so that's what we've built on top of Redis. We have a Redis Enterprise software version and a Redis Enterprise Cloud version that's fully managed that you can leverage through Google Cloud's console, through their marketplace. It is a core technology partnership with them. So you can do things like fraud mitigation, real-time inventory, forecasting, leaderboards for gaming, caching, session management, customer 360 for retail, claims processing for healthcare, and a recommendation engine, just to name a few. This technology is really built to be your data platform. And we've built on top of the Redis open source technology, which we are the home of. We continue to commit to the open source technology and build and innovate on top of that, but also build the enterprise features and technologies that users need as they grow with their data and as they begin to build out modern applications. And so Redis Enterprise delivers unique value. Performance at scale, no speed and scale trade-off, right? So as you go into hyperscale, maintaining that sub-millisecond latency, which is what we mean by real time, that's the only way you're going to have real-time applications. Optimizing TCO. So a lot of folks will come to us and say, well, in-memory is very expensive. We have a Redis on Flash capability that allows for you to scale in an optimized total cost of ownership fashion. Doing more with your data and modules, building those applications, modernizing those applications that were previously legacy. Operational flexibility, a fully serverless cache and database management system that is completely abstracted away from you. No more of the management concerns. Instant failover, high availability with 5 nines with active to active. Being able to scale up and scale down elastically, all within one data platform. Developer productivity, so you no longer have to worry about managing your open source Redis or your caching service or your database. You can simply focus on what your business needs are and really move the needle for your business. And so growth happens, right? Open source is great for many, many different use cases, right? As building a small development environment, testing out with Redis. These are all great use cases for open source Redis, and it continues to be leveraged by many, many across the world, developers and architects alike. Google Cloud Memory Store is Google Cloud's Redis fully managed version. It's 99.9% SLAs, runs exclusively on GCP, and is great as that next step for fully managed Redis. But beyond, when we look at scale, when we look at performance, when we look at enterprise use cases, there's many of those that can be used by Redis Enterprise Cloud and should be used in this data platform. And that's the next level. It's sort of a crawl, walk, run. And if you're looking and you're trying to get to that next level, you're building applications that are real time, that are mission critical for your business. 5 nines SLA, hybrid and multi-cloud compatibility, enterprise grade features, right? The active that I talked about, the modules, Redis on Flash, and many, many more are why folks are moving to Redis Enterprise Cloud above and beyond the open source version. All right, and with that, I'm going to go ahead and pass it over to Lili. Thank you so much.
Thank you, Ryan. Hello, my name is Lili Seif. I'm the Global Strategic Alliances Lead at Google Cloud, where I manage databases, including Redis Labs. I'll walk you through the Google Cloud and Redis partnership today. When Google Cloud launched the open source initiative for our open and free and our open source partners, our goal was to deliver 3 main benefits to developers. First is a unified experience. We want them to discover tools that they already use through the Google Cloud console and to be able to deploy these tools easily and efficiently. The second benefit to developers is unified support. Google wants customers to examine the support cases they have opened and drive them to a resolution with full visibility, allowing users to track and resolve open cases in a single pane of glass. The third initiative is unified billing. Many customers are making large commitments with Google, and we want to encourage those customers to use partners like Redis. So what we've done is allow customers to deduct from their commitments they've made to Google for the third-party services they purchase from Google Cloud in a single unified bill. This dramatically simplifies procurement and makes accessing software easier than ever. Beyond the three benefits I just shared with you, with Google Cloud, you get end-to-end security, flexible deployment options, fully managed operations, AI and ML embedded in all services, and more. Let's dive a little deeper into what makes Google Cloud different. We deliver end-to-end security solutions from the data center all the way to the device with a purpose-built infrastructure and security by default. We believe in an open cloud and have designed Google Cloud to support whatever system best suits your needs, whether hybrid or multi-cloud or something in between. We strive to make cloud easy to use, automating manual tasks and configuration wherever possible, so your teams can focus on development and less on managing infrastructure. We embed intelligence in everything, making it easy for you to apply artificial intelligence and machine learning in your own organization. Lastly, we bring you the best of Google in all of our solutions, and we can help you create a more innovative and collaborative culture in your organization. So why use Redis Enterprise on Google Cloud? Well, Redis Enterprise Cloud and Google Cloud are better together. As you've heard throughout this webinar, Redis is a lightning-fast data store that can be used both as a cache or a database. It is highly available, durable, and linearly scalable. You can create modern applications for popular use cases such as fast search and indexing, real-time inventory, AI-powered fraud detection, and more, all from one data platform without the need for having single-purpose tools. As I mentioned in the beginning of my presentation, with unified billing, you get a single bill from Google and your purchase counts towards your overall commit. In terms of deployment, you have multiple options. I'll quickly run through them now and let Gilbert, Redis's resident evangelist and cloud partner solution architect, take a deeper dive later on in the webinar. Redis has three options. First is the self-manage option, which is downloadable software purchased through Redis Labs and installed on Google Cloud, Compute Engine, or the infrastructure of your choosing. Second is also self-managed, but it is GKE, which stands for Google Kubernetes Engine, and is purchased through Google Cloud Marketplace and Anthos certifies. This option works well for customers who want more control, or if they're adopting a multi-cloud strategy, or if GKE is important to their application. As mentioned throughout my presentation, purchasing from Google Cloud Marketplace allows for unified billing, and that your spend will count towards your Google Cloud commitment. Last option is fully managed and hosted. It is purchased through Google Cloud Marketplace and managed by Redis Labs. This also allows for unified billing, and that your spend will count towards your Google Cloud commit. And wherever you are, we most likely have a region available near you, as we now have a worldwide footprint with 21 Google Cloud regions. This delivers fast performance and better data locality options, which can be critical in the GDPR era. Redis Enterprise Cloud and Google Cloud deliver unparalleled benefits. Boost your operational efficiency. Redis's fully automated service lets you deploy Redis Enterprise on Google Cloud in just a few clicks. You can automatically scale your database without any interruption to your applications and grow your dataset to any size with no downtime. Handle your peak traffic spikes. Redis delivers fast, predictable performance. Powered by a share-nothing architecture, Redis Enterprises delivers virtually infinite linear scaling for your apps to instantly handle millions of requests a second with sub-millisecond latency on Google Cloud's fast global network. Built to support a microservices architecture, Redis integration lets you deploy any number of completely isolated databases under the same Google Cloud subscription. Once you create a subscription, you can launch or delete new databases in just a few seconds with no additional operational or infrastructure costs. Built-in resiliency to overcome the toughest outage scenarios. Safeguard against every type of failure with high availability, instant failure detection, and single-digit seconds failover across regions and availability zones. Big cost savings. Redis Enterprise includes Redis on Flash, which offers a unique ability to run very large databases at significant cost savings, and durability backup and disaster recovery. Protect against data loss, even in cases of multiple node or zone failures, and allow fast recovery in case of complete outages. Data can be persisted to disk every write, every second, or with point-in-time snapshots to Google Cloud Storage without affecting performance. In conclusion, I'd like to read you a quote from the CTO of ShareChat on why Google Cloud was the right choice for them. Google Cloud was our cloud partner of choice, given its superior technology, secure and high-performing infrastructure, and cost-effectiveness. We were also able to build a high degree of trust with Google's team that made this seamless migration a reality. Thank you for your time today. Next up is Gilbert Lau, Redis's resident evangelist and cloud partner solution architect. Take it away, Gil.
Thank you, Lili, for the great introduction. Let me kick off by talking about some of the key drivers for real-time. Cloud obviously provide an agile and scalable platform for running today's always-on and real-time applications. In this part of the presentation, we are going to discuss how Redis Enterprise powers the real-time data layer for modern application, specifically on Google Cloud. So it's no-brainer. I don't have to convince you that most today are moving to the cloud to trying to become more agile and to reduce cost. It is also no secret that most companies are either on the cloud or on their roadmap already. So some large enterprises today already went all in with the cloud and hybrid cloud. The company without a solid cloud strategy are going to be replaced or going out of business very soon. The reasons are there is a promise of significant value across building new application quicker to gain new business insights with streamlined data, reduce the burden of operations, and also cut down on costs. One other reason for that is being able to scale your data along with your business needs, as clouds allow for elasticity of resources for seasonal workload. It's extremely important to retailers as the business runs with seasonal pattern. Being able to scale the business up and down instantaneously without over-provisioning infrastructure provides significant cost saving. Cloud-native apps are one of the most talked about topics in the developer community in the past several years. With the abundance of cloud and becoming the de facto platform for running workloads, enterprises or startups are leveraging the cloud to build cloud-scale, cloud-aware applications to meet the business needs. As the result, these new applications run in a cloud-native fashion to provide always-on and real-time capabilities at global scale. By 2021, over 50% of all online sales from food, retails to health science will be processed through mobile. Apparently, it has been accelerated by the COVID-19 pandemic. Mobile ordering food, delivering through DoorDash becoming a standard lifestyle for our population. So Redis Enterprise is at the top of the stack when it comes to providing a real-time modern application, real-time application, enabling cloud migration and accelerating cloud-native application development. It provides a real-time data layer for any modern applications, leading data in sub-millisecond response time. So the 5.9 availability for your business critical applications, sub-millisecond latency at cloud scale due to its in-memory nature, active cluster geo-replication supporting both read and write in different GCP and geographical regions. The Redis Enterprise modules extend capability to provide developers with multi-model data support, which is a great fit for microservices. Do more faster. Redis Enterprise also reduced the TCO of running multiple databases in a single cluster. And it also reduced the overall TCO of running Redis Enterprise NoSQL database in the database as a service fashion in the stack. Pay for what you need and use. Last but not least, Redis Enterprise is available as a fully managed service as well as self-managed services on Google Cloud, depending on your use case. The modern application required to be always on, scalable, real-time, multi-platform support would definitely appreciate the value Redis Enterprise brings to Google Cloud. So the movement of applications from running on-prem to the cloud, the movement of building cloud-native applications in the foreseeable future. However, companies part of this movement are facing different challenges. Can they migrate existing application to cloud if it's overnight? The answer is no. Can they simply build application in the cloud and claim them cloud native? The answer is no again. Let's look at the challenge next. So there are several ways to modernize an existing application. First technique is lift and shift approach by migrating existing VM-based workload from on-prem data center to public clouds. The most straightforward and less risk involved. This approach could only reap the benefits such as better utilization and availability of cloud resources. But it is not making the application more scalable and more responsive, thus not cloud native. Second approach is by building new cloud native applications as replacement of existing application or for net new applications. So these normally take longer time to market than adding on top of existing monolithic application, as the company are just starting to build cloud native applications. More importantly, most enterprises do not have the right talent or skill set to build cloud native application. I'm not saying it's going to continue like that. Overall, the long-term benefits of building cloud native application are far better approach in terms of agility and scalability. Speaking of cloud migration, the lift and shift approach when migrating to the public cloud, this is normally not a single event. Companies gradually move their workload from the on-prem data center or private cloud to the public cloud. Some of them are required to operate in a hybrid cloud environment. Hybrid cloud compatibility is normally a challenge in that regard. It is quite possible that data cannot be migrated with the applications. In such environment, data is fragmented between private and public clouds. On average, organizations need 3 different databases to manage data across hybrid and public clouds. These create a serious and long-lasting data silo problems. Duplicate copies of same data is everywhere. Managing data and ensuring their consistency in such environment is very difficult and error-prone. So once the applications are migrated to the cloud, the availability expectation of this application is increased. Any cloud-based application can only support up to only 3 nines. Availability are considered to be not meeting the passing score. Breaking down a single monolithic application into a suite of autonomous microservices increase the complexity of the underlying architecture significantly. It usually makes it more expensive to manage, more complex to monitor and troubleshoot issues. Be many interdependent microservices working in a chain and coordinated fashion to complete a single task. So management and security of these many microservices are difficult. Without a proper tooling or monitoring system, IT becomes slow to respond when issues arise. Deploying hundreds of microservices without visibility or secure control will turn management of this application into a nightmare. So nobody wants the application modernization effort becoming a counterproductive act. Cloud native is great, no doubt about it. This is the future of application needs to be cloud native. While cloud native provides many benefits such as agility and efficiency, it also brings new set of challenges, such as a platform which can provide hyperscale and elasticity, how they can run in a hybrid or multi-cloud fashion, how they can address data distributed across the globe while providing low latency. We need a fully automated toolchain which can run the application at cloud scale, accessing data in a geographically distributed fashion in real time. The latency for local data read and write needs to be under sub-millisecond, while time to replicate data across region close to real time. This way, cloud-native applications will be able to meet the mark of providing low latency and real-time experience. The real-time data layer is an integral part of any cloud-native application infrastructure. With that, let me transition to Eddie, who is the principal architect at Google for application modernizations. He's going to talk about Google Anthos, an application platform for modern applications running in hybrid and multi-cloud environments. Here you go, Eddie.
Thank you, Gilbert. Everyone, my name is Eddie Villalba, and as Gilbert mentioned, I'm the principal architect for our application practice here in North America and cover Anthos for majority of our large enterprise customers. And as Gilbert mentioned, many of the challenges that we see customers facing today with bringing cloud-native apps and applications to their environment are really about how do we solve or how do we look at this ability to stretch across multiple cloud, hybrid cloud, and bring a platform that can answer all of these challenges. And as you may think, Google is a cloud provider. Why would we be even thinking about that? And while the future, while we focus on cloud, the future isn't just cloud. It's really about multi-cloud and hybrid cloud, and we've seen this over the last few years. And you can see things such as just our own data, $92 billion expected size of the hybrid cloud market just in 2021 alone. That's just from our customers telling us exactly what they need and what they require from their business case and from the new types of applications and services they're trying to deliver and where their data sits. RightScale, through their information through their customers, 72% of enterprises will be pursuing a hybrid cloud strategy in 2018. So as you can see, this is going as far back as 3 years now, where we identified that all of these enterprises need some type of way to stretch all of their application, their data, to wherever they need it to be, including on-premises, including multiple cloud providers. And then obviously Gartner giving us information going as back as 4 or 5 years now that hybrid cloud is a true strategy and it's just going to be increasing. So we looked at this problem and we understood we are a cloud company. What are those benefits? What are they really looking for? And we talked to many of our large enterprise customers and we saw things like diversifying risk, cost management, vendor lock-in, being able to make sure that they can control their infrastructure and their cloud partner provider as necessary. Businesses or tech partnerships with multiple cloud vendors in cases they're strategic partnerships that they have and they require to run data or run services in any of those cloud providers. They want to increase resilience and availability. Believe it or not, again, we will see that cloud vendors do go down. You see it. There's outages on a regular basis. But these enterprise customers, they want to deliver high level of services to their customers, in some cases life-saving services. So the only way to really do that is to leverage against all of these different cloud providers and make sure that they increase their resilience and availability that way. And then obviously backup and disaster recovery to make sure if they're running primarily on premises, they can actually recover and go to the cloud if necessary. With those risks, obviously, there are some challenges. Increased operations and management overhead. Now you have to have people that need to also understand all of those different clouds. So now we have additional skill set needs. Now you have to understand how each cloud provider works, how they're architected, how they're built, and design across those. There's complexity of your tool chain and your tools on running multiple environments in your native platform. How do I run my Java app or my Angular Vue front end on one cloud provider's app service or web service compared to another's? What are the dependencies? How do I build that into my tool chain process? There's a high level of initial migration costs, especially when working with multiple clouds at the same time. And then there's service dependency. Many times I'm building to potentially a cloud service that only exists in that cloud, and I'm not looking at how I can potentially leverage a platform that is cloud agnostic and can deploy across multiple clouds. And now I've built in some service dependency and lock-in at that point. At Google, one of the things we always think about is how does Kubernetes, how does this idea of a containerized orchestration platform solve some of these challenges and also answer some of these benefits? So why Kubernetes? First, it's open source. It's one of the largest growing projects in the history of the open source community. It's been adopted by many enterprises across the globe, and its growth has been unprecedented in the way that we can now deliver applications and manage our application delivery in an agnostic format. Huge community support, the amount of vendor support, community support, and the ecosystem around it is so large that in many cases, there's just really no other choice out there where I can deliver what I need as an enterprise on a platform that has this large level of support. It's vendor agnostic. As long as you meet your conformance platform, your Kubernetes distribution or the Kubernetes distribution that you might be using will work across both cloud, multi-cloud, and also on-premises. It's also one of the only containerized platforms that's supported by every major public cloud provider in the world today. It offers faster development life cycles. You can now, and we've seen customers be able to deploy apps much faster with Kubernetes and containerized platform. And it's beginning to drive new levels of efficiency in development platforms and bringing new capabilities to market for many of our enterprise customers. It's an efficient use of underlying infrastructure, especially with a hybrid mode. I can now increase the density even beyond what virtualization was able to give me, and now run multiple workloads on a single piece of hardware, and I can reuse all of that existing hardware. And because of its footprint and varying footprint, we're now seeing Kubernetes running on things such as Intel NUCs or very small, low power, low processing capability hardware. So now we can see Kubernetes running at edge locations, in data centers, and even in some devices as well. And because of its self-healing and self-running nature and declarative state engine, which Kubernetes really is, it makes this operations around Git, control and Git operations a reality for not just your application, but how you deliver your application, your infrastructure, and everything around it. So how does GCP and Anthos work for this app modernization process? One of the things that we want to look at is how do we put your compute next to your data with a purpose-built hybrid and multi-cloud platform based on open source technologies and created with Google know-how and new Google power. How do I achieve consistency across security, connectivity at scale with all of these innovative technologies that you're used to and you're seeing across the ecosystem? How can I get a value-added experience for new and existing workloads? And how can I take advantage of potential Google Cloud capabilities even on my on-premises environment or another cloud provider? things such as hybrid AI and BigQuery. And more importantly, this is a partnership. I want to make sure that whatever solution I choose, I experience an end-to-end partnership focused on long-term success. So that's where Anthos comes to play. Anthos is a Kubernetes-based platform that runs everywhere you do, with a cloud-backed control plane for centralized management, that single pane of glass that you're looking for. So looking at being able to do cluster management, lifecycle management, configuration management, policy management, service management, day two operation management, and more importantly, security across my entire fleet of systems in Google Cloud, on AWS, on Azure, on vSphere, on my bare metal servers, or even existing managed Kubernetes environments such as AKS, EKS, OpenShift Kubernetes server. But I want to make sure that not only do I get all of the base kind of management capabilities, but I also get application management, infrastructure automation, end-to-end observability, and compliance and governance that comes along for the ride. All of this built on the power of the most powerful managed Kubernetes environment, and of course, the first ever in the public cloud, Google Kubernetes Engine, or GKE. So if we look a little deeper into the Anthos stack, we look at, obviously, your landing zone. Where do you need your environment to run? On Azure, on AWS, on Google Cloud, on Edge, on a vSphere environment, on bare metal servers that you want to continue using and potentially leverage your existing investments, or you have attached clusters or managed cluster environments from already other existing cloud providers, and you have workloads already running on them. And then I want to begin to manage of those, and I want to begin layering different components around policy management with Anthos Config Management, service management by looking at all of my individual services that I develop at a network layer with my Anthos service mesh built on Istio. I want to have an API connectivity with security and single access and single sign-on. That's how I get Anthos Connect Gateway connects me to my Kubernetes API. I want to leverage the power of cloud to make sure that I get consistent logging, monitoring, and tracing of all of my application and my workloads and the system itself. So leveraging cloud ops, cloud monitoring, cloud tracing with our operation stack across my fleet. Management console, being able to have one single pane of glass and be able to see all of my systems, regardless of where they are, across my fleet, and manage my workloads across the fleet. And then be able to use things like the GCP Marketplace, Cloud Run for Anthos for serverless type capabilities, BigQuery Omni, Looker, Apigee for API management, and be able to deploy all of that, again, consistently across all of my systems wherever they may exist. That's the power of Anthos. And if we look at it deeper, what I'm building is really a platform that I can extend my existing GKE or GKE environment, the power of GKE that we currently have. And now I can express that through to third-party platforms by using their compute, storage, and network available on those platforms or on-premises, and then be able to extend all of these capabilities onto there. And then more importantly, begin leveraging our third-party partners and services. More importantly, how do I get my data, my management across? And that is where we leverage things such as Redis Labs to be able to deploy and manage your data across this entire fleet. Now that you have a compute platform that is giving you that capability across both multi-cloud and hybrid cloud. Gilbert, back over to you.
Thank you, Eddie, for explaining to us why and how GCP and Anthos provide a robust platform for application modernization. Now let's discuss what Redis Enterprise is and its characteristics around speed and performance, and how it powers the real-time data layer for modern applications. Redis is the open source technology. It is the in-memory database and is fundamentally known for speed and performance. Redis Labs, on the other hand, is the home of Redis, a commercial provider of Redis Enterprise. We are the primary sponsor of Redis OSS by employing the original creator, Salvador Sanfilippo. The Redis Labs succeeded him as the project lead in 2020. We have put together a new community-driven governing body and continue to encourage passionate developers to contribute to the project. I'm going to walk you through some of the specifics of what makes Redis Redis. So the fundamental problem that is at the core of Redis is simply about speed. For the modern applications, there's very little time to absorb or deliver data required, and making it accessible to a large number of application servers and devices. Solving that problem is at the core of Redis. Finding someone or something in a hurry to read and write some data, and I think you have got a very good potential Redis use case. The Redis consistently produces less than 1 millisecond of latency and a million of operations per second. It provides the data the fastest it can. So the way this system, this functionality was envisioned, and which continues today, is in its name, a remote dictionary server. Remote means from an application servers, dictionary alluding to the key value nature of the data. Server is simply a server. It's more than that though. It's extremely fast. It was clocked in the lab at 200 million operations per second. The data type is served, while simple, and ubiquitous in more than 60 programming languages out there, making it very simple into almost every application to consume and very attractive to actual communication model is extremely simple, making it very fast and easy to understand. All in all, it not only solved immediate speed and latency problem, but it solved it elegantly. So it is very easily consumed by application creators, thus increasing developer productivity. So Redis Enterprise is not just a key value in-memory database. It has much more than that. At its core, it consistently provides sub-millisecond latency under any workload. The finite uptime, availability with this active geo data replication across GCP regions. You can multi-tenant multiple databases on a single Redis Enterprise cluster, as well as using Redis on Flash for tier memory access to lower your TCO. This forms a very solid foundation for core use cases such as enterprise caching and primary real-time database. Next, Redis Enterprise modules extend the capability of Redis key value pair dictionary server to support other data types such as JSON, time series data, stream graph, and search capability are also available from Redis Enterprise. They all run on a single integrated platform. Finally, Google Cloud has the most extensive and sophisticated AI and machine learning APIs. Redis Enterprise provides the AI serving capability to present recommendations in real time through the phases of AI-powered modern application running on Google Cloud. Modern applications are usually dealing with data in real time and in highly available fashion. Multiple copies of the same data are available in different geo would help modern applications endure natural disasters and other unplanned downtime events. Active geo replication from Redis Enterprise allows read and write to any Redis Enterprise cluster in different GCP regions at the same time. Local latency is always under 1 millisecond, even if globally deployed. also support hybrid cloud deployments such as one cluster running in GKE cluster in Google Cloud, and another cluster running on the Antho bare metal cluster in customer data center. Redis Enterprise CLDT-based active-active technology guarantees low latency for fault-free and write operation with automatic conflict resolutions. Our customers use this technology for a variety of reasons, either to unify their data sets across clouds, between on-prem and cloud, or as a disaster recovery plan, which is a critical technology for running the always-on modern applications. Lastly, what set Redis Enterprise apart from other solutions out there is its speed. It managed to provide 4 times better performance than other alternative data platform solutions in general. Some enterprise modules produce up to 100 times better performance than its competitors. Redis Search, Redis JSON, Redis Graph, Redis Bloom, and Redis Time Series enable new modern use cases with an extraordinary speed along with 5 nines availability. Everything under one roof, reduce complexity, and improve overall TCO for all kinds of real-time data processing needs. Next, we're going to talk about Unity technologies. Customer story. One of the very large joint customers between Google and Redis Labs. But this customer has a very successful implementation of Redis Enterprise running on GKE for providing the real-time 3D content creation and operation platform. The quote from the customer is, they wanted to provide a standardized solution for Redis on GKE for the internal users, but one that has to be reliable, scalable, and also include a world-class support. That's when they first started to evaluate Redis Enterprise and the Redis Enterprise operator for Kubernetes. So they represented the DevOps teams and started toying around with the operators. And the team was amazed at how resilient the operator was and how it fit right into the existing tool chain of GKE and Google Cloud. So what they have confirmed from the evaluation was that Redis Enterprise is a robust and solid technology powered their real-time data layer on GKE. So Unity is the world leading platform for creating and operating interactive real-time 3D content. Their platform provides a comprehensive set of software solutions to create and operate content for mobile phones, tablet, PC consoles, and augmented and virtual reality devices. They had a very impressive accomplishment in the year of 2020, really shine by the numbers. They have achieved in many different aspects. 5 billion downloads per month of applications built with Unity. About 71% of top 1,000 mobile games were made with Unity. 50% of games across mobile, PC, and consoles were made with Unity. About 2.5 billion monthly active users who consume content created or operated with Unity technologies. 20 plus different platforms run these creations. About 190 plus countries and territories have Unity creators. To conclude, they have a huge footprint in real-time 3D content and gaming industry. Their platform proliferates and penetrates so deeply that almost 1/2 of the content we access every day is built using Unity technology platform in any shape or form. So when Unity first migrated to GCP, They built an open source Redis solution using GCE virtual machines and home-rolled Terraform modules for cluster or Sentinel for Redis outside of Kubernetes. This required advanced init script files also for service discovery and even more pain point across the board. Let's talk about the transformation journey and the resulting platform architecture next. So the legacy architecture showing on the slide, it provides some flexibility for developers, but became a major headache to maintain and orchestrate. The solution required manual intervention, especially around Redis version upgrades or resizing of an existing cluster on virtual machines. One of the largest issues with the early attempts at providing Redis for developer was the difficulty level involved at creating a single new Redis cluster with Terraform module. The solution required in-depth knowledge of all the moving parts, like understanding how console works, how Sentinel was involved, at scale. This quickly turned into full-time team member being nearly entirely devoted to existing clusters. Additionally, Unity runs all of the applications on Kubernetes. At the time they built the legacy solution, there wasn't a reliable way to run persistent database inside Kubernetes. Some of the developers started trying to use some Redis inside GKE using some open source solutions. But inevitably, they would always run into problems. They wanted to provide a standardized solution for Redis on GKE, but one that needed to be very reliable, scalable, and as I said earlier, need to include the world-class support. That's when they first started to look at Redis Enterprise and the Redis Enterprise operators for GKE. So moving to Redis Enterprise and Operator for GKE allowed them to enable development teams to spin up new Redis Enterprise database through YAML manifest. Remove the worry and overhead around node management, allowed for swift failover with less client disruptions, and also to eliminate Sentinel for high availability. These friction-free operations avoid many unnecessary human errors and boost overall productivity at the same time. As an added bonus, the client code did not need to change. They could use Redis Enterprise as a drop-in replacement for the legacy open-source Redis databases. Running Redis Enterprise in GKE alongside with services also reduced developer friction in the time it takes to get test, staging, and production infrastructure set up. What used to take a few days now can easily be done in a single day. So workload that previously relied on the open source Terraform module to build large Redis cluster usually require upward of 20 plus GCE VMs. Split between some Sentinel node and Redis nodes. As they migrate this workload into Redis Enterprise, they have been able to provide sub-millisecond latency for high throughput services on a fraction of infrastructure needed before. Because their workload are running in GKE, and the Redis Enterprise operator can be the cluster local on its own node pool that reduce network latency while improving resiliency due to the zone-aware, highly available nature of Redis Enterprise operator, the intelligence of our operator. In conclusion, this new optimized platform not only save costs for the customer, but also improve the overall SLAs. So now it's perfect time to show a demo of continuous delivery toolchain for running a real-time modern application on Google Cloud. It is a fictitious real-time consumer banking application using Redis Enterprise as the backend real-time data store running on GCP. So let's look at the architecture of our demo system. I'm going to show you two flavors of using Redis Enterprise on Google Cloud. The first one is self-managed Redis Enterprise. Two chain on the top consists of many components from GCP. It has source code checked into GCP source repository. Google Cloud build triggers to generate and publish new Docker image, update and apply Kubernetes YAML manifest, and deploy the newly built Docker image onto development GKE cluster, staging cluster, and production cluster. We provision Redis Enterprise on these GKE clusters through the GCP Marketplace offering for Anthos GKE. In each of the GKE cluster, there is a self-managed Redis Enterprise cluster backed by our Redis Enterprise operator for day-to operations such as upgrade, scaling, or scans, and new database creation. Redis Enterprise deployment option is also provisioned through GCP Marketplace. So this option provides customer with database as a service experience where they only need to define the size and throughput, such as operation per seconds. Requirements of the database. Redis Lab take care of the rest and ongoing maintenance of the Redis Enterprise cluster, hosting the database instances. The two chain on the Google Cloud remain the same. The difference between this fully managed enterprise model versus the self-managed model on Anthos GKE is where the Redis Enterprise database are running and how they're being managed. The latency difference between these deployment models are very insignificant, as Redis Enterprise cluster are both running on Google Cloud. So enough said. Let's dive into the demo, as seeing is always believing. So the demo will cover a walkthrough of the continuous delivery toolchain in Google Cloud and how the toolchain reacts to update made to the source repository, and how to move from development to staging and to production. And finally, a feature walkthrough of our sample real-time retail Spring Boot banking application powered by Redis Enterprise module, Redis Search, and Redis Time Series. Let me go ahead and start the demo. Let's start off with the toolchain. The source code of a retail banking application is hosted on GCP Cloud Source repositories. It is tightly integrated with Google Cloud. One can check out the source code and start updating it all inside a browser. Banking application is a simple Spring Boot application, as you can see from the screen. It uses Redis Enterprise as the primary database in the backend. This is the YAML manifest to deploy a Docker image for banking application. It takes the Redis Enterprise database connection parameters such as service name, database port, and database password through a Kubernetes secret, which was generated by our Redis Enterprise operator for Kubernetes. This is the service manifest YAML to expose the web front end of the banking application. In our toolchain, we use GCP Cloud Build to orchestrate the GitOps style operations, manage the banking application from development to staging and to production. It is fully automated through Cloud Build triggers that we will discuss in just a moment. The YAML that you are seeing is to orchestrate a life cycle of a code change in the development branch of the source code repository. In general, there are 4 stages a code change needs to go through in the pipeline. We start with compiling the Spring Boot application source code and generate a respective Docker image. Next, we would run a series of tests to ensure the updated banking application functions properly. Here in this demo, we are not implementing any test cases. Then in the pipeline, it publishes the newly built Docker image, Google Container Registry, with a development label. Finally, it deploys the new banking application to a development GKE cluster, functional and usability testing. These are the 3 triggers we have built for this demo application. The top one, namely Redis Bank branch, is the trigger I just showed you a moment ago. The other triggers are to pretty much do the same thing, but depending on the Git operations being applied to the source code. Redis Bank master is a trigger when merging code changes from a development branch into the master branch. Redis Bank tag is a trigger to be used when the master branch is tagged and when we are ready releasing it for production. Let's do a live code change to the banking application. First, create a new development branch called dev202. All we are doing here is to update the dummy text file. Then we are going to apply and push the code change back to the source code repository. Redis Bank branch trigger was activated. It started running through the pipeline for building a new Docker image and deploying the updated banking application to a development GKE cluster. The whole process generally takes 2 minutes to complete. Once done, I can access the updated banking application in the development GKE cluster. This is the front page of the Redis Enterprise banking application. So far, I've shown you how the continuous delivery toolchain we have set up in Google Cloud to accelerate the development and deployment of a cloud-native modern application. Now this part of the demo is to demonstrate the value of Redis Enterprise being the real-time data layer for a modern application. Redis Enterprise Bank is a retail banking application. It's an always-on modern application serving retail banking customer with real-time data. This is the same Spring Boot application we deployed through the continuous delivery pipeline in Google Cloud. Let's buckle up and log in to realize the real-time experience of this banking application as a premium bank customer. Redis Enterprise database behind the app not only serving as a caching layer, it's the primary and core use case for Redis in-memory database in many places. That it is being used as a primary database to store all the banking application data. Due to Redis speed and performance, we're able to deliver data in real time and in an always-on fashion. Here's my bank account information. Top, we see the checking account summary, where I spent my money in different categories. Scroll a little bit down and we will see the banking transactions in real time. Use Redis streams, native Redis data structure to ingest real-time bank account holders' transactions. Redis streams can collect large volumes of data arriving at extreme high velocity. It effectively manages your consumption of data even when producers and consumers don't operate at the same rate. The graph here representing the bank checking account balance over a time period is plotted using Redis time series data structure. It is showing the checking account balance at different points in time of today. It is so fast that customer can literally see the bank account balance up to the last 1 second. Another great usage of time series for financial institutions is to manage the data for stock prices. Let's continue our demo and do a search on how much I've spent at Starbucks for my coffee needs. I will start by typing the word Starbucks. Prefix search feature from Redis Search is intelligent enough to find data matching when I only type up to star and presents them in the window below in real time. This instance and real-time experience is unprecedented in today's banking applications. Another thing I want to find out is the auto loan payments for my BMW. Let's do a search on it. Data again is shown pretty much in no time. In summary, Redis Enterprise is designed for speed and performance. Scale linearly, extremely well, and produce sub-millisecond response time in all situations. Plus, is multi-model data structure support. This app uses a few critical data structures and modules from Redis Enterprise. Redis Search, it provides full text search and secondary index search capabilities. Redis streams to ingest and process real-time data at high frequency. Redis time series to handle time-related and sensitive data in real time. Redis Enterprise has other modules such as Redis Graph, Redis JSON, Redis AI, which can always satisfy your ever-changing data requirements. It becomes more crucial when building microservices, where each of them may need a specific data structure. Redis Enterprise is perfect for building modern applications, requiring always-on and real-time experience. More and more applications are using Redis Enterprise as their primary database. Redis Enterprise and Google Cloud Platform together provide a comprehensive toolchain, developing, deploying, managing any modern applications. With that, I'm going to pass it to Anisha from Google to talk about the Google Cloud Marketplace. Here you go, Anisha.
Thanks, Gilbert. Hi, everyone. I'm Anisha Nanda, Product Marketing for Google Cloud Marketplace. I know we have referenced the Marketplace multiple times today, but for those who are new, the Google Cloud Marketplace is a modern digital store for cloud solutions. It really provides all of our customers with a curated catalog of solutions, and it's the one place for customers to find, purchase, deploy, manage, and govern best-in-class production-ready solutions that are built by both our partners as well as Google. So first, let's take a quick look at how these transactions flow through the marketplace. The entire process is super simple for both the development team as well as the procurement team. The development team really identifies an IT need, and they let procurement know what they want. Procurement simply goes into Google Cloud Marketplace, one central location where they can evaluate all of these solutions. They can look at pricing options, they can create agreements with partners if it is a negotiated deal, or simply they can just go and click and buy. At that point, the development team can access the solution from Google Cloud Marketplace to fulfill it. A lot of our customers actually experience a variety of benefits besides what we just see when they purchase third-party solutions from Google Cloud Marketplace. Let's take a quick look at a few of them. So the first one that I always like to talk about are the financial incentives. This is definitely a big driving force for our customers. The first thing that they can do is really draw down from the GCP commit if you already have one. So if you have a GCP spend agreement, solutions procured through the Google Cloud Marketplace will count towards that committed GCP spend. And then second, you can actually use your GCP credits as well to procure both third-party solutions from our marketplace. Makes it super simple for you to draw down and bring that commit up to speed. Another big one for us really is procurement as well. So you can actually accelerate that procurement process for both you and your teams. You'll be able to purchase without the need for an internal vendor review if Google is already one of your preferred partners. And then for future uses, you can also create a scalable and repeatable procurement process with deployments that are already integrated with Google Cloud. And then finally, just in terms of vendor relationships. So as a user, purchasing through the marketplace simplifies and consolidates all of your vendor relationships for you. You can get solutions to your team super fast by eliminating the need for separate billing agreements for each of the partner solutions that you use. So purchases from Google Cloud Marketplace will have Google as a seller of record, and they'll simply be added to your GCP bill. So you really only get one bill for all of your purchases. All of this really simplifies the use of the marketplace, but with that, let's learn how you can actually use Redis and how that helps you realize the promise of the cloud. So Redis is available as a fully managed service as well as a self-serve model on Google Cloud Marketplace. You can use it for enterprise-grade applications as well as real-time use cases like Gilbert just showed us. It includes enterprise features, both Redis on Flash, HA, as well as modules with one click. And then you can subscribe to these directly from the Google Cloud Console. With a simple setup, unified bill, and your purchase counting towards your Google commit, it's as easy as that to get started. I hope you enjoyed learning briefly about Google Cloud Marketplace. And with that, I'd like to hand it off to James.
All right. Thank you, Anisha, and thank you to all of the speakers today. I really enjoyed the session and the information, and I hope everybody listening learned something new. If you're interested in diving deeper, we have a lot of great resources out there for you to take advantage of at redislabs.com. If you want to connect with us directly, please send us an email at googlecloud@redislabs.com.